Data structures for symbol table. Symbol table is a vital data structure, created and maintained by the compiler, to keep track of the semantics of variables. It stores information about the scope and necessary details on names and instances of several entities, like names of variables and functions, classes, objects, etc. Let us have a look at the format of symbol table. A symbol table is simply a table, which can be either linear or a hash table. Each item in the symbol table has properties like name, kind, type, and others, as given below. This symbol table entries are created by analysis phase and used by synthesis phase. Items stored in symbol table are NBSP, variable names and constants, procedure and function names, literals, constants and strings, compiler-generated temporaries, NBSP, labels and source languages. Operations of a symbol table. The core operations of a symbol table are allocate, free, insert, lookup, set attribute, and get attribute. The allocation operation creates an empty symbol tables, the free operation is used to remove all records, and free the storage of a symbol table. As the name implies, the insert operation puts a name into a symbol table, and returns a pointer to its entry. The lookup function looks up a name, and returns a reference to the corresponding entry. The set and get attributes associate an attribute with a given entry, and get an attribute associated with a provided. Other steps may be introduced depending upon the requirements. For example, a delete action deletes a previously entered name. Symbol table. Different data structures are used in implementing a symbol table, such as linear list, self-organizing lists, that is linked lists, binary search trees, and hash tables. Here is the representation of symbol table using list, and advantage of list organization is that simple compilers use the least amount of space feasible. The list is broken into two sections: unordered list, used for a modest number of variables, and ordered list. In this, the cost of insertion is high, but the process is straightforward. Disadvantage is searching takes more time if the array size is larger, i.e., ON. Next is implementing symbol table using self-organized list. This implementation is using a linked list. A link field is added to each record. Searching of names is done in order pointed by the link of the link field. A pointer first is maintained to point to the first record of the symbol table. NBSP insertion is fast, that is order of 1, but lookup, that is searching, is slow for large tables, order of n on average. Here you can see how the symbol table is represented using linked lists. Hash table for symbol table. In hashing scheme, two tables are maintained, a hash table and symbol table, and this is the most commonly used method to implement symbol tables. NBSP, a hash table is an array with an index range table size -1. These entries are pointers pointing to the names of the symbol table. To search for a name, we use a hash function that will result in an integer between 0 to table size -1. Here you can see the representation of symbol table using hash table. Insertion and lookup can be made very fast, that is order of 1, and the advantage is quick to search as possible, and disadvantage is that hashing is complicated to implement. Binary search tree for symbol table. Another approach to implementing a symbol table is to use a binary search tree. That is, we add two link fields, that is left and right childs. All names are created as child of the root node that always follows the property of the binary search tree. Insertion and lookup are order of log 2n on average. Symbol table contains left child, symbols, information, and right child as fields. Advantages are insertion of every symbol is efficient. Any symbol can be searched using binary search efficiently. Disadvantage is it consumes a lot of space in storing left and right pointer. Hope the concept is clear. Thank you.